Hello everyone, welcome to Computer Aided Design class. I am Rakesh, Assistant Professor in Department of Mechanical Engineering, Kids Warangal. In this video lecture, I am going to explain one important topic in Computer Aided Design. The topic name is Hermite cubic splines. The topic name is Hermite cubic splines. Before going to explain this topic, uh, let us discussing about mathematical representation of curves. These curves are basically divided into two types. One is analytical curves, analytic curves. Second one is synthetic curves. Here, analytical curve means the curves which are defined by analytical equations. For examples are circles and ellipse, circles and ellipse. In synthetic curves, the curves which are formed by a set of data points, example cubic splines, cubic splines, comma B spline and beta spline, B spline and beta spline, beta spline. In CAD/CAM system, the synthetic curves can be generated by interpolation or approximation. Interpolation or approximation. Here, interpolate curve means the curve passes through all data points. Let us see one example. This is the one curve. This curve passes through all the data points. This is the example for interpolate curve. Let us see the example for approximated curve. A smooth curve is approximated through the data points. Let us see, this is the one curve. This curve passes through the nearest of given data points. This is the example for approximation curve. These synthetic curves are divided into three types. One is Hermite cubic spline curve, Hermite cubic spline. Cubic means order is 3. Cubic spline curves. Second one is Bezier curves. Bezier curve. Third one is beta spline curve. Beta spline curve. In today class, we will discussing about Hermite cubic splines derivation. Parametric spline curves are defined as piecewise polynomial curves with a certain order of continuity. A polynomial of degrees n has continuity of derivatives of orders n minus 1. Parametric cubic splines are used to interpolate to given data, not to design free-form curves as Bezier curves and B-spline curves. Splines draw their name from the traditional draftsman tool that is called French curves or splines. The Hermite form of a cubic spline is determined by defining positions and tangent vectors at the data points. The parametric cubic spline curve, it is also called cubic spline for short. It connects two data endpoints and utilize a cubic equation. Let us see the graph. Just you can see here. This is the x-axis. This is the y-axis. This is the z-axis. I am taking one curve. This is the initial point, that is P naught. This boundary condition is u equal to 0. This is the end point, that is P1. This boundary condition is u equal to 1. And the two tangent vectors at these 2 points. This is the one tangent vector, that is P naught dash at boundary condition u equals 0. This is the second tangent vector, that is P1 dash. This boundary condition is u equal to 1. These 2 points gives a Hermite cubic spline. Now the parametric equation of a cubic spline segment is P of u equal to summation I equal to 0 3 Ci u power I, 0 less than or equal to u less than or equal to 1. This is the equation number 1. This equation represents the parametric equation of a cubic spline segment. Here u is the parameter, where u is the parameter and Ci is the polynomial coefficient. This is the polynomial coefficient. Or algebraic coefficients. Now you can write this equation in the scalar form, that is x of u equal to, here I equal to 0 to 3. Right, you can take I equal 0, that is C0 u power 0. Next substitute I equal 1, C1x u power 1 plus C2x u power 2 plus C3x u power 3. Now first I am taking I equal to 3, that is C3x u cube plus, next I am taking I equal to, that is C2x u square plus C1x u plus C0x. Similarly you can write y of u. Just you can replace x with y, that is C 3y u cube plus C 2y u square C1y u plus C0y. Similarly, write z of u, that is C3z u cube plus C2z u square plus C1z u plus C0z. Now you can assume this is the equation number 2. Now, uh, now you can write the parametric equation of a cubic spline uh, in the format of coefficients, that is P of u equal to C C3 u cube plus C2 u square plus C1 u plus C naught. This is the equation number 3. This equation can also be written in a matrix form. You know how to write this equation in the matrix form, that is already you studied in the finite element methods, that is P of u equal to u transpose C. This is the equation number 4. Here see the coefficient vector, that is C equal to C3 C2 C1 C0 transpose. Next, where u is the parameter vector, that is u, capital U equal to u cube u square u1. Similarly, you can write the tangent vector to the curve at any point is given by differentiating the equation number 1 with respect to u. We get p dash of u equal to, you can differentiate equation number 1 with respect to u, that is summation I equal to 0 to 3 ci the constant, ui derivative is, that is similar like x power n into x power n minus 1, that is I into u power I minus 1. Limits are 0 to less than or equal to u less than or equal to 1. This is the equation number 5. You can also write p dash of u equal to, you can also derivate this equation number 3 with respect to u, that is C3 u cube. U cube derivative 3 u square, that means 3 C3 u square plus C2 constant u square derivative 2u 2 C2u 2 C2u plus C1u derivative C1 constant u derivative 1, that is C1. Here C0 derivative constant, so 0. So no need to write 0. Here in a, you can see the equation number 3 and this is the equation number 3 and equation number 5. We are having few constant, that is C0, C1, C2, C3. In order to find the coefficients, that is Ci, consider the cubic spline curve with the two endpoints. Already I shown the previous page, that is initial point is P0, end point is P1. Now apply the boundary conditions for P0 and P0 dash. Now applying the boundary conditions. Applying the boundary conditions. that is at u equal to 0 and for p naught comma p naught dash at u equals 0 and you can also calculate p1 comma p1 dash at u equal to 1. Now I'm taking initial boundary condition that is u equal to 0, p of 0 equal to, now you can apply the initial boundary condition, the equation number 3, p of 0 equal to c3 0 cube, c3 0 cube plus c2 0 square plus c1 0 plus c naught. The answer is p naught equal to c naught. This is the this you can assume this is the equation A. Next, similarly, you can substitute this initial boundary condition in the this equation, that is p dash of 0 equal to 3c3 0 square plus 2c2 0 plus c1. The answer is p naught dash equal to c1. Let us assume this is the equation B. Now you can take secondary boundary condition, that is u equal to 1. Similarly, you can apply the second boundary condition in the equation number 3 and equation number 5. You can take also this the 5. P of 1 equal to C3 1 cube plus C2 1 square plus C1 into 1 plus C naught. Now substitute previous equation, that is C naught equal to P naught and C1 equal to P naught dash in the this equation, that is P1 equal to C3 plus C2 plus C1. Here C naught equal to P naught plus P naught. This is the equation number C. Similarly, you can apply the second boundary condition, that is u equal to 1 in the equation number 5, that is P1 dash equal to 3c3 into 1 square, that means 3c3 plus 2c2 into 1, that is 2c2 plus c1 means p naught dash plus p naught dash. This is the equation number D. Now simplify this now simplify this equation C and D. You can get C2 and C3 values, because here C2 and C3 are unknown values. By using these two equations, you can determine C2 and C3 coefficients. You can see here, uh, you can simplify this equation C and D. Just you can multiply this C with 3. That means 3p1 equal to 3c3 plus 3c2 plus 3c1 plus p naught. You can see here c1 means p naught dash. You can substitute in the place of c1, that is p naught dash. Now simplify this equation C and D. First one is p1 equal to c3 plus c2 plus p naught dash plus p naught. Second equation is p1 dash equal to 3C3 plus 2C2 plus P naught dash. Okay, from this equation you can write C3 plus C2 equal to P1 minus P naught dash minus P naught. From this equation you can write 3C3 plus 2C2 equal to P1 dash minus P naught dash. Now simplify these two equations. You can multiply this equation with 3. You can write 3C3 plus 3C2 equal to 3P1 minus 3P0 dash minus 3P0. Second one is 3C3 plus 2C2 equal to P1 dash minus P0 dash minus plus. Now these two terms are get cancelled. Remaining terms is 3C2 minus 2C2 is C2 equal to 3P1 minus 3P0 plus P0, that is minus 2P0 dash minus 3P0 minus P1 dash. Here 3 is the common in these two terms. Just take 3 as common. 3 into P1 minus P0 minus 2P0 dash minus P1 dash. This is the C2 value. Now you can substitute this C2 value in the equation, this equation you can get C3 value. Okay, from this equation you can write C3 equal to P1 minus P0 dash minus P0 minus C2, that is C3 equal to P1 minus P0 dash minus P0 minus C2, that is minus 3P1 plus 2P0 dash plus 3P0 plus P1 dash. Now simplify this equation, you can get 2 into P0 minus P1 plus P0 dash plus P1 dash. This is the C, this is the D. Now substituting the C1, C0, C1, C2, C3 in the equation number 3, you can get P of U equal to, here P of U is C3 U cube plus C2 U square plus C1 U plus C0. Now substitute C0, C1, C2, C3 in the equation number 3. That is C3 is 2P0 minus 2P1 plus P0 dash plus P1 dash U cube. U2 is 3P1 minus 2P0 dash minus 3P0 minus P1 dash into U square plus C1 is P naught dash U plus C3 is C naught is P naught. Now simplify this equation. We get P of U equal to you can simplify this equation. You can take P naught as common, P1 as in terms of P naught, P1, P naught dash, P1 dash. First, you can take P naught as common, that is 2 U3 minus 3 U square plus 1. You can see here 2 P naught. In this 3 P naught. Here P naught. Take U P naught as common, 2 U3, 2 U cube. Here minus 3 U square. Next plus 1 into P naught plus take P1 as common, minus 2 U cube plus 3 U square into P1 plus next take P naught dash as common, U cube minus 2 U square plus U into P naught dash plus U cube minus U square P1 dash. This is the equation number 6. Here P naught, P1, P naught dash, P1 dash are called geometric coefficients. Here this P naught comma P1 comma P naught dash and P1 dash are the geometric coefficients. Geometric coefficients. Now you can write this similar like for tangent vectors, that is P naught P dash of U. Similarly, you can substitute C naught, C1, C2, C3 in the equation 5. That means this equation you can get P dash of U equal to 6U square minus 6U into P naught plus minus 6U square plus 6U into P1 plus 3U square minus 4U plus 1 into P naught dash plus 3U square minus 2U into P1 dash. This is the equation number 7. This is in the form of tangent vectors. The functions of U in equation number 6 and equation number 7 are called blending functions. These two equations are called blending functions. Blending functions. Equation number 6 and 7 are called as blending functions. The first two functions blend P naught and P1, and the second two blend functions are P naught dash and P1 dash to produce the left hand side in each equation. Now you can write equation 6 in the matrix form. Now you can write this equation number 6 in the matrix form, that is P of U equal to U transpose MH V. Now you can write this equation number 6 in the form of matrix form, that is U transpose MHV, that is 0 less than or equal U less than or equal to 1. This is the equation number 8, where MH is the Hermite matrix. Here MH is the Hermite matrix. Hermite matrix. And V is the geometry vector or boundary condition vector. Now you can write MH value by using equation number 6, that is 2 minus 2 UQ terms in first row, that is 2 minus 2 1 1, that is 2 minus 2 1 1. Now write the second row, that is U square coefficient minus 3 3 minus 2 minus 1 minus 3 3 minus 2 minus 1. Similarly write the third row, that is U coefficients. Here in the first P naught U is not there, you can take 0. Next one 0 1 0. Now write the fourth row is constants, that is 1 0 0 0 1 0 0 0. This is the Hermite matrix. Similar write tangent vector, that is geometry vector or boundary condition vector V equal to P naught P1 P naught dash P1 dash transpose. This is the equation number 10. In previous MH is the equation number 9. This is the equation number 9. Uh, Comparing equation 4 and 8 show that C equal to MHV. MHV. You can write V MH inverse into C. You can calculate MH inverse, that value is that matrix is 0 0 0 1 1 1 1 1 0 0 1 0 3 2 1 0. You know how to calculate inverse of the given matrix. Uh, similarly, you can similarly equation 7 can be written as P dash of U equal to U transpose MH power U into V. Here MHU is given by MH power U is given by 0 0 0 0 6 minus 6 3 3 minus 6 6 minus 4 minus 2 0 0 1 0. You can follow the previous procedure. You can get this MH power U matrix. This is the equation number this is the equation number 11. This is the equation number 12. This is the equation number 13. You can see the equation number 6. This equation describe the cubic spline curve. This equation describe the cubic spline curve in terms of two endpoints and their tangent vectors. The equation shows that the curve passes through two endpoints, that is u equal to 0 and u equal to 1. It also shows that the curve's shape can be controlled by changing its endpoints, that is P0 and P1, and its tangent vectors P0 dash and P1 dash. If if the two endpoints, that is P0 and P1, are fixed in space, the designer can control the shape of the spline by changing either magnitudes or the direction of the tangent vectors, that is P0 dash and P1 dash. This is the brief discussion about Hermite cubic spline. I hope this is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more videos.